So today we're going to talk about mastering integration tests with test containers, and just to, it's in general a very interesting topic. I would be talking a little bit about maybe a little bit more advanced usages of test containers libraries for your integration tests in your Java applications, and we're gonna look at some code. We're gonna talk a little bit about the kind of sort of the premise. Why do we need integration tests or functional tests at all? And I, uh, yeah, we'll see. Right. My name is Oleg Šelajev, and I work at the company called Atomic Jar, which is a little startup. Well, not so little anymore. Created by the maintainers of test containers Java libraries. We're building the cloud backend for the test containers tests, and we're trying to maintain and enhance the test containers libraries for a number of languages. You can find me online, so if you don't get a chance to ask questions, I'd be happy to chat with you online about anything. Well, about anything, to be honest. Yeah, so you can find me all this. So let's talk about tests. Tests are very interesting, and I think testing our code is a fundamental thing that all developers should do. We do know that having better and more appropriate tests improves the quality of our software, and this is something that we all should be striving for, is to have a software of a better quality. I personally truly believe that if all software would be better, we would live in a better world, um, which might not be absolutely true, but there is something to it. And very often, to all the questions that we have in software development, the answers are the tests. Can I merge this pull request into the main branch? Do you have tests, and do those tests pass? If yes, then probably you can. Can I deploy a certain version into production? Do you have tests, and do the tests pass? Can I how can I be sure that I'm actually improving towards like fixing or adding new functionality that I want? I need to write tests that test that functionality and then verify that they run. And then hopefully they will fail at first. And then eventually they're going to get better and better and greener and greener. And then eventually they'll be like, oh, yeah, our tests pass. How I can be sure that while I'm working on my piece of like the next issue that I'm resolving, how can I be sure that I'm not stepping on anyone's toes, that my teammates will not hate me when I break the build or when I break their code? The answer to that is tests. Or like, well, I run my tests, you run your tests, you run my tests, everyone runs our tests, the CI runs tests. Like when everyone runs tests, software development is smooth and nice. There was a question to Venkat, like, why do you want to write unit tests, and whether this is not like a waste of time? Because when you think through what you're writing, like the code that you're developing, then adding unit tests doesn't contribute that much to the understanding of the code that you're trying to write. And then can answer that the tests are the guardrails to prevent the future regressions, which is definitely true. But also, you don't have to write unit tests. Sometimes you can just write higher level tests that very often are better at checking against the regressions. Just need to pick the right level of abstraction to test, and that's it. Sometimes you don't have to write unit tests if you have different ways to check the application behavior. How do you? What's the answer to having like a silky and luxurious hair? You'd think it's test, but it's mostly personal hygiene and genetics. Uh, but tests are, if you thought about that test is answer to that, I like the way you think. So you're in the right track. Right. So let's talk about tests. How do we structure tests? What do we have in mind when we think about tests? Very often, when I say tests, people immediately imagine like a testing pyramid like this. And we developed this sort of understanding, how do we test software? And it looked a little bit like this for a number of years. We would have our application under test, and then we have the tests organized in different layers, different types of tests, if you will. At the bottom, we'll have many of unit tests, where unit stands for like a single component of our application at a different scale. It could be a class, or it could be a single function or a method that you want to test, or it could be a little library that you are calling from your application, and anything that kind of relates to that library calls you can put in a unit. But the main point is that there will be many of those, and they will cover all possible scenarios of the individual components. And then on top of those, you'll have integration tests. They will be slower, bulkier, harder to maintain, maybe a little bit flaky, because they will test different components together. Maybe your application was a database. Maybe how your JIT compiler works together with the garbage collection in question. Maybe how two windows can open up together if they're a corner window. A number of things. But you test your application in conjunction with other components. And then, because they are harder to maintain, and there will be less of them. And then at the top of that, we have the end-to-end tests, which are even fewer in numbers, and mostly, usually, people tend to cover only the happy path for the end user interactions with your applications. And they would run, for running those, you would need to recreate the environment similar to the production environment. So you will spin up your cloud, and you will run your application server in that, or your application, and then you will have uh, all the services around that that are also used in production. And then you would plug your application into that situation, and then use that and verify that it behaves as it should. And they're very hard to maintain, because they can fail for a number of reasons, not just depending on your application. So the reason for why a test like that could fail could be somewhere elsewhere, because there are other applications in play there. And that's why there will be fewer of those, and they will be separate. So, and that was a number of years ago. And then, with the recent developments in how we develop software, we started doing the testing a little bit differently. There are a number of different teams that came forward with how they reimagined this testing pyramid. And one of them is the Spotify team, uh, who said that with migration to the microservices architectures, with their applications looking different from before, they started rethinking the amount of tests and what tests they write. And they would have a fewer implementation detail tests, which are not unit tests in itself, but they check the business logic of the individual code that we're writing. If I have a function that concatenates the strings, or reverses something, or manipulates data in some way, that is the implementation detail of the business logic, and it will be covered with the implementation detail test. Whether that is a unit test, or whether that needs to call into like 73 additional libraries loaded through reflection on the fly, that is a question nobody knows. Very often people do not know what their application are doing when you actually call a method. It might look like a simple thing, but there could be like a ton of background machinery behind that. So there will be implementation detail tests. And then the bulk of the tests that would be the integration tests, which will test the components and their applications in a sort of simulated environment, with some of the necessary components and services present, but locally. They will run them the same way on the developers' machines, on the CI machines. They will test the components with the necessary components around them. Maybe databases, maybe message brokers, maybe, I don't know, Elasticsearch servers, and so on. And they will have some integrated tests, where the application under test, the application they're developing right now, is integrated in the like sort of the production like environment. And there would be fewer of those. And the bulk of the test suite, the tests that they will rely on to say whether a certain commit can be rolled into production or not, would be integration tests. And this is a very interesting notion, that we first there is a switch of what types of test application developers create, and second, what tests they rely on to make decisions. Think about this, right? When we follow the DevOps practices, we have this continuous delivery of software in the phase where we plan and build and code and release the software, and then we monitor how it behaves in production, and then that feeds back into the planning and so on. So a very important part of that DevOps 8 is the testing thing. Before we release something in production, we actually have to verify whether that whatever we coded works or not. And it's not just for the changes in our code. It's not just when you are typing something in your ID and then saying like git commit, git push. It's also for all the changes that our application undergo. For example, there are a number of changes that come with the transitive dependencies, and they're very important. Think about the security aspects of this. One of the major essential things that will simplify your application security is a good test suite, because you can apply security fixes and roll them out into production within as fast as possible. How can you verify that your application doesn't send data to rogue LDAP server because of the logging library if you don't have a test for that? And if you do have a test for that, then the situation becomes very simple. You can update the libraries in question. And this is, of course, a hypothetical example that is sort of vaguely references the Log4j situation that happened like in winter last year, like a eternity ago. But how can you test the security fixes? You update your dependencies, and somebody discovers vulnerabilities, and they're rarely in your personal code. They're often in the code that some other people wrote, and then you just depend on. It could be your application framework, it could be your dependencies, even as like innocent looking as the logging library, right? And then somebody looks at that, discovers the vulnerability, discloses that vulnerability, maintainers fix that thing, and then you get a report from your security software saying, oh, you need to update the things. If you have test suite that you can trust, you just you update, you run that, you're like, yeah, stuff works, release that into production. If you don't have the testing suite that can tell you that a certain thing works or not, then you are in a big trouble. Because even if you get the security fixes from somewhere, you don't know whether they break something for you or not. And this is incredibly frustrating because well, what's the point of having security fixes if you cannot roll them out? It is just as good as not having them. So, test is one of the, equally important, but one of the most important phases of the DevOps practices. And I personally feel that very often we kind of turn a blind eye to that. We assume that everyone tests their code, but very often people have put more attention on the other phases of that, and then we get into situations where stuff breaks, which is very unfortunate. So we all agree that we should test. Hopefully, we all sort of understand the premise that we can test applications at different levels of abstraction and at different kind of sort of complexity levels. And I would argue that functional tests are essential for proper application security practices and the proper DevOps practice. So let's talk how we can get those functional tests, those integration tests in the proper shape as a developer, because you don't want to make them fragile and struggle. That's where Testcontainers comes in. Testcontainers is a collection of libraries that integrate on one hand with Docker as an environment to create your ephemeral service dependencies, your database, your Kafka, your Elasticsearch, your cloud technologies, your I don't know, anything, your HashiCorp Vault, or any technologies that your application relies on. And on the other hand, it integrates with your application framework or with your code directly or with your testing frameworks to provide you with a seamless API to connect and to manage the lifecycle of those things. Testcontainers is available in different languages, so it's not just a Java thing, but the Testcontainers Java implementation is the most advanced currently. Mm, well, I don't want to sound very negative towards other languages. It's we will, as at Atomic Jar, we would love to support all the Testcontainers languages, but our experience is mostly in Java. So that's where we're working on the most currently. But the other languages are community implemented implementations, and you can contribute to those. And when we get more resources, engineering resources specifically, we would love to bring them all to the same level of functionality. They are all usable, they are all great. And it's not just me talking about that. Recently, the ThoughtWorks Technology Radar put Testcontainers firmly into the adopt category for the languages and frameworks with the incredibly flattering description. We think it's a useful default option for creating reliable environments for running tests. It's programmable, lightweight, and disposable, make our functional tests more reliable. Reliability here is mentioned twice, which is a very important concept. You want your tests to be reliable. If your tests are not reliable, if your tests are failing for no reason, then you cannot trust them. If you cannot trust them, they're just like a bother that you need to go through the motions running tests and then rerunning them again until they are green. They don't give you any indication whether the software you're working on and creating, whether it's good or bad, or whether it's working or not. You need to have reliable way to run your tests. So, and Testcontainers helps with that quite a bit. Of course, it's not just by itself. It stands on the shoulders of Giant, and as I mentioned, Testcontainers integrates with Docker. So it relies on the Docker's ability to create this unified API to run other people's software locally on your workstation or in your CI environment. Docker provides you with the way to ensure process isolation and the configuration for software and application within the containers. And then with configuration, how to access those things. It's a little bit awkward to use Docker command line utility for integration tests specifically, because in the integration test scenarios, you want to have different scenarios. You want to have different services running depending on the tests that you're running currently. So you need more control. Specifically, you want to have a better lifecycle and cleanup control. You want to have a little bit more flexibility for the service configuration within the container, and perhaps the better integration with the frameworks that you are using in your favorite programming language. So that's where Testcontainers comes in and takes care of that for you. Testcontainers Java is a very, very mature project. It was created 7 years ago. And if that doesn't sound like, oh, this is like ages ago in Java years, because, well, Java is what? How old is Java? 26, 30, 26, 27 maybe years old now. So, but for comparison, Docker was created 8 years ago. So very soon after Docker was created and started getting popular, uh, the community realized that more flexibility would be beneficial, and tighter integration with frameworks like Spring or JUnit would be beneficial. It's an open source project, of course. It's the sources are on GitHub, so if you have any issues or if you want to help us maintain that, please just go and well, be a part of the open source community there. What Testcontainers does, besides just checking and talking to Docker, it tries to create this reliable environment for you. It does a number of checks to verify that the Docker environment and the Docker implementation is compatible, and it can do what you want to do from within almost any test that is running with Testcontainers. It checks whether you can configure to expose ports, like send files back and forth, and so on. It does extensive care for the cleanup. So when you run your test, you can run in any number of containers, and then after your tests pass or fail or even crash, the containers will be cleaned up ensuring that when you next time you run the tests, it will get the repeatable environment again and again and again. So the environment your tests are running with depend only uh, on the tests themselves and the configuration within tests. So there is nothing lingering. So you cannot connect to like an outdated Kafka from the previous version and thus fail the test run because of the external reasons. It also tries to emphasize and kind of shepherd the developer into writing integration tests that follow the best practices. For example, very often working with the Docker, you need to expose software via the network, you need to expose the ports. Test containers randomize the host ports that our services are exposed on, so there are no port conflicts. And test containers has a number of ways to configure services within the container to simplify the data-driven tests. For example, uploading and creating your schema in a database. And of course, you like the it's written with the idea that you can run your tests in parallel, which is not always easy when you talk about the external services running in the Docker containers. But we try our best to alleviate the problems there and make sure that we can run tests in parallel. It also comes, test containers Java comes with the large ecosystems of modules, which are the libraries that somebody in the community created for the particular integration with the technologies that you want. For example, do you know how to run Kafka in a container? You might not, but as an application developer, you don't have to, because you rarely run Kafka in production yourself. You might be using a managed service, or there might be some other people who actually know how to run Kafka. You might not run Kafka in production in a Docker container. So for your tests, what is important that you want to say, I want to work with the real Kafka instance, please create one for me. And the libraries, the modules that test containers has offers the abstractions for running Kafka or Neo4j or MySQL or Red Panda or even the Kubernetes if you want. So there are a number of technologies that work with all this, and of course you can run anything that runs in the Docker, and it will be created in this ephemeral Docker container, run that, and then cleaned up after, allowing your tests to be reliable, working with the real world technologies. As I said, there are implementations of test containers in different languages. So there is a Go version, there is a Node.js version, which you can use with TypeScript or JavaScript. There is a Python version, there is a .NET version, there is the test containers Rust. I know somebody is working on Twitter on test containers PHP, which is I think a very interesting exercise uh, in creating a useful library. And those are community contributed, they are open source. I think most of them, or either maybe even most of them, are under MIT license, but they are all open under open source licenses. So even if your teams within the company are not just Java or JVM language specific, then they can also benefit from using test containers. So that's it. That's it. Let's look at how it works in practice. I'm gonna look at the Spring application example here, and we're gonna create a few tests, and we're gonna create those ephemeral environments for the tests using test containers. The application is fairly straightforward, but just for the simplification here, it talks about the sessions at the conference and the ratings for the sessions. And it has two application components within it. It is a controller for ratings that uses the repository that talks to a relational database. And then ratings controller and ratings listener, two classes in my application, they communicate using Kafka message broker. So the controller will send Kafka messages, and the listener will listen to the Kafka messages and then process them, and then store additional data in the Redis key value store. It might be a little bit of an overkill for such a simple functionality, but the good thing about this application is that it relies on a number of third-party services for being able to run. So let's see how it works. I have my application here, right? It's a Spring application, and it does exactly this thing that I told you. We have the ratings controller, which uses Kafka through the Kafka template, and then it stores the ratings in a Redis key value store. The exact functionality here is not super important. We just need some code so we can create tests on the higher level. But the thing is, we use those technologies. We use the Tox repository that goes to the database and runs SQL queries on that through the JDBC template. It can be anything. Our tests are also here. And there's a good collection of tests. We verify that the context loads and that our database contains the sessions by the ID that we want. We verify that our Spring application actually starts and returns that it's healthy by itself, that the health endpoint returns to 100. We check the high-level functionality of our application. So we're going to send the HTTP queries to that with the new ratings for the particular talk, and then we're going to post them to the URL that you've seen. We had those in the ratings controller that we map to the ratings URL, and then we're going to wait for the redirect back, and then we're going to assert that when we get the ratings with the same talk ID, then we're going to get the ratings that we have. And this is interesting. And then we would just do the same in a loop to show that it actually depends on, well, we get the different ratings back as well. And we even have the negative tests here that the application returns for a foo when we get the talk that was not specified before or is not in a database. So we have a decent collection of tests. They're all high level. They will not break if we refactor something within the application, if we don't change the interface that is available to the other services. So this is the great benefit of the functional tests. And we're using two cool libraries here that I want you to know. One is Rest Assured. So for example, from Rest Assured, we get the ability to send requests and this Fluent API to specify which requests to send. We also have the predefined request specification here in the parent class, just to avoid some boilerplate for this example. So before every test, what we do, we specify that we send the request to the port where our Spring application is running. So we specify that we want to run it on the random port, specifically because we want to run our application maybe in parallel for the parallel tests. So we set the specification to access exactly that port, and we say that we're going to send JSON back and forth. And then using that request specification, we can just say, use the Fluent API to send things. And then the other thing that we do is we use the library called Airway Utility, which is a great library to work with any asynchronous events. So when we send the ratings, we know that it needs to propagate through Kafka, and then it needs to come back through the Kafka listener and be stored in the ratings database. And that might take a little bit of time, depending on the application and the rules. So in our test, we're going to wait until the either a timeout strikes or we're going to get the result that we want from here. That is possible. Together, Rest Assured and Air Utility give you an excellent toolbox for writing your highly functional tests. And yeah, so we're going to work with this test suite, right? I can run these things. They will of course fail because our application needs a number of services to run with, right? We need the database, we need Kafka, we need Redis, and those are not there. So what can we do? We can create those, right? So our application just fails because nothing is there. Mostly it fails because it doesn't find the database, so it cannot wire the builds together because there is some misconfiguration, right? So I'm gonna create those. In a nutshell, what I need to do, I need to add the containers dependencies to my dependencies, right? So I can put the individual modules, so work test containers, and then particular services that I'm going to use. Kafka for the relation database, we're going to use Postgres, so I'm adding Postgres here. But there were all the modules that I talked about with the technologies that simplify testing against the actual Kubernetes cluster or actual MongoDB and whatever other technologies. And I add the kind of sort of the main test containers core and test containers JUnit integration dependency together here, and that's it. Right after that, I'm good to go. So come back. Right. So we're gonna do it here. The one of the main abstractions that we need to know is the generic container. So what I can do the generic container, and I'm gonna say this is Redis, and this is a new generic container, and I can run whatever I want there. So I'm gonna do Redis, um, and then I'm gonna specify the tag for the Docker image name, what I want to have, and this is our Java object that corresponds to the container with Redis that we're gonna run. Test containers will take care for the rest, and you can see immediately here that I can have all the configuration that I can do with Docker. I can expose reports, I can create networks, I can copy files, I can create the dependency chains on those, I can override the commands, and I can get files from the container and to the container. I can do anything that I can do with Docker container from my Fluent API. I'm going to expose the port 6379 because that's the internal port on which Redis will start. And it will be mapped to a random high-level port that I can get through this Redis instance. I'm going to say that this is a static field instance, and I can manually start and stop the container. So you can see that I have the lifecycle methods there. They are doing I/O, so they're going to throw exceptions. So I'm not going to start them there. So this is our Redis, pre-configured and created. I can also do the other things. So for example, if I want Kafka, then it's even easier, right? I can somebody wrote the module for Kafka, so I don't need to know all of this. How to run Kafka? Do I need to run it with a Zookeeper or without the Zookeeper? What are the Bootstrap servers? So how to create the URLs for that, or how to configure Kafka to uh, advertise the correct URLs because we run with the randomized ports. So I can just say, give me my Kafka, and this is my new Kafka container, right? And I have the API to do whatever I want here. So we're gonna use Confluent Inc. CP Kafka. I think it was CP Kafka. Yes, CP Kafka 546. Is this correct version? Right. There is this nice support with the IntelliJ JetBrains IDEA. Well, no, JetBrains IntelliJ IDEA ID. So it gives me contents assistant, the Docker image names here. But this is I can do the Kafka containers just with one line of that, and I can do also the Postgres. I'm gonna say that I want my Postgres container, uh, Postgres container. Okay, a new Postgres container. Uh, and then we can just Postgres, 14 Alpine. Is it Postgres? Yeah, okay. Right. This is my Postgres. Now, I have declared what containers I want, and now I need to run them. And I can run them. I need three things for my application tests. I need to declare which service dependencies I need. I need to manage the lifecycle of those dependencies. So I need to start and stop them. And you can do either manually, or you can use the JUnit integration where you tie the lifecycle of those containers to the lifecycle of your unit tests, or anything like that, or maybe a support from your application framework. And the third thing is, when I run my tests with my application, I need to communicate to my application where my services are running. It will what good it is that I'm running Postgres in a container if my application doesn't know that it runs there. So I'm going to use the thing that's called dynamic property source method in the Spring setup things in the Spring implementation. Right. So what I need to do, I need to have this method that is static and marked with the dynamic property source that takes the registry. And in that method, what I can do, I can say that registry at the certain configuration. For example, we can do Spring Redis host and then give it a host. How do we know what's the host, what's the IP of the Redis? Well, we just do what? We can ask it from our Redis abstraction, and we do the same with the port, and we get the mapped port, which is the high value port that we have in the thing. We can do the same with Kafka at what was it? Spring Kafka Bootstrap servers, and then I can just do Kafka Bootstrap servers, right? And then I can do the same with database, right? I need to do the same with database. So that is what registry add, add Spring data source URL, and then I can do Postgres get JDBC. No, not the password. Get JDBC URL. Very good. And then we do two more because I need password and username. Name, and then here we do password, and then here we get username, password. Now we have our full configuration here. We create and configure our Spring application to use all those things, and it's gonna run, and the test will pass if we start the containers, right? So I'm gonna start all the containers here. What do I need? Redis, Kafka, Postgres. They all gonna start in parallel here using this thing. So, and I'm gonna wait for them to start before I will configure my Spring application. So this is all I need to define what I want to run my tests. So if I run now my demo application tests, I think they should pass because they will run within the environment that is sufficient for my application. Hopefully here, what will happen is that initially Testcontainers libraries will check that it is connected to a Docker environment, and it will do the tests that the Docker environment is correct and it can run and configure things. It will pull the Docker images. And it will start our applications altogether. You can see that now it is starting Kafka. It marks the log lines coming from Testcontainers with the nice whale icon, which corresponds to the idiomatic like animal that can be used to ship containers. It can pull the containers. Why is it not working? Oh, of course. Our application loads and it is healthy because it knows that where the database is and everything, but our data is not initialized there. How can I initialize data in my container? There are a number of ways. One of the simplest ways, you can rely on your resources, application YAML. You can rely on the Spring or your application framework initialization mode that will create that. You might not want to do that, and if you have some sort of a schema files, either real life world schema or for your tests, what you can do, you can just initialize that. So let's do that. We're going to use and copy the schema file from class parse resource schema SQL, right? And we're going to copy it in the predefined location within the container. And then we're going to use the container functionality to load that file. So if you look at the container definition, init with the init scripts, initialization scripts, right? If we put our scripts into a predefined location there, we can very easily just go with the thing. Right, so I'm gonna copy it there. I'm gonna copy it there. And now I'm gonna rerun the tests. Let me just run the context loads just to verify that the application will start. So what it does, it puts the schema file in the location within the Docker container. And when my database starts, it will just run this thing for me. Now, the tests are fairly quick, and the tests are fully isolated. So every test, I can create as many containers as I want specifically for that test. Here we create those containers once per application, and you can see my test passes here because now I have the schema. Let me just rerun all the tests while I'm talking. So here we create those containers once per the application startup, which lowers the isolation level. Not every test gets a fresh containers, but at the same time, we don't start those containers again and again and again all the time, which helps us with speeding up the test suite. You can do even more. One thing that you can do here, for example, is you can specify that you want to reuse the containers, and you can see well, after this you don't see it, but the containers are cleaned up. There are no containers running after I run my tests. So, but I can also specify the reuse mode. This is interesting. So I can I do all of them? Yeah, I think I can do all of them. So it's incredibly useful for the local development modes, local development specifically, where I can say, I want to reuse those containers. I want to like remove them from this automatic cleanup, which is very, very interesting. So now I can run those tests. And at first, the first run will be no different. At first, this run will be no different because it needs to restart the containers and start them again. But after that, I can run my application, and the containers will be already there. They will not be cleaned up because we specified that we want to reuse true. There is also the Testcontainers properties file in the root of my user that specifies that my environment supports running reusable containers, because you don't want to API, you don't want API like that just to run without uh, the environment consent. So you don't want your containers linger when you run it in a CI on a beefy machine or anything like that. You want the environment to say that yes, I can support reusable containers, and then you want your API here defined that, oh, please let me work with the reusable containers. So you can control the life cycle very like to the best of your ability as well as you want. Right. So let's see the logs here for any of the tests, just to make sure that the reusable containers were already used. So we asked for Kafka, and that Kafka container was the hashed configuration that we provided from the API as the identifier was found. So we are not creating one. We are just reusing the container that is already running. And this works really, really great for us, right? And then you can do any complexity setups that you want. So what I would like to show you here is a setup with Toxiproxy to sprinkle a little chaos engineering into this thing. So what I will do now, let's remove that. I will do the network. I will create the static network for my containers so they can reuse the network. Network, new network. And I will say that my Redis can be with network, and I can specify that I want it to be called Redis on the network. And I will create a new static proxy container. Proxy, new proxy container. It's a Shopify's thing. So Shopify, we can do proxy, and then the version, let's say 201. I know that the 201 works. And we put it on the same network that we want. So now the proxy container, what it does, it integrates with Docker, and it will be able to control our network. And we're gonna refactor our test to use Redis through the proxy container, and then we will be able to control what it means to access Redis. So first, I need to start my proxy here, right? And I have just a few
Sorry,
minutes, and
Oleg.
that will be enough. I don't have minutes. I have 3 minutes, right?
Yes, but we have some questions also.
Oh my
Maybe
god.
you can
Okay, okay.
do it quicker.
Okay, let's do it. Yeah, I can do it. I can do it very quickly. I can do it very quickly. So let me just run this like this, right? I will specify the proxy we're gonna run with the latency proxy, and we're gonna make it be very slow to access our Redis. So we're gonna access that Redis, and then I just need to configure that Redis hosted port to go through this proxy thing, right? And now when I run this test, like for example, this particular run test rating test, we're gonna see that it takes, I don't know, like 20 seconds or 30 seconds, because it takes 2 seconds to access Redis at all times. Right, while this runs, I'm happy to answer all and every question that we have. I just want to show how cool it is and how easy you can introduce very complex setups into your test containers based tests. Irina, you there? Right, you can see how slowly it reacts to me. Boom. 20 seconds. Before it was 5 or 6, right? So this is one because we introduced the latency. You can cut the connections, you can do anything you want, and you can create very, very complex setups here, which is, I think, is great. Very flexible. Perfect.
Thank you so much. Thank you, Oleg. It was really interesting and a lot of questions we have in our chat. But sorry, we are running out of time, so I will choose the first one and ask you to answer.
Okay.
So, how to speed up integration tests when for each test application context and test containers must be restarted in order to have a clean state?
Yes, that's one of the that's where the proper uh, container lifecycle control comes into play. If you really need that level of isolation that you need to restart the containers all the time, that start time will accumulate. It's not that long, but if you run like hundreds of tests, it will still be starting hundreds of the containers. So there are two things. One, I would try on, if I were you, I would try to look, maybe my test can run with some shared state. So for example, starting containers per application run, or per like some test groups that I want to isolate from each other. So for example, tests that mess with the database schema and create the improper state will be with their individual instances, and tests that are kind of sort of with the good citizens checking the proper application usage will be different citizens, right? So this is one. And this other part is I would verify that my Docker containers have enough resources. So that can speed up running and starting containers considerably, especially if we are talking about the heavier ones like maybe Kafka, maybe Elasticsearch. Very often, you're just giving Docker more resources speeds up working with those containers. But mostly, I will just refactor my tests into different groups.
Okay, thank you so much, Oleg.
And
We
oh,
don't
sorry,
have enough time.
of course, run your tests in parallel. That's very important. Parallelization is key. Excellent. We don't have any more time, so you'll have to figure it
Yes,
out on
yes,
your
but
own.
I have one very quick question. Is this demo available on Git?
Yes. So this is the test containers slash workshop on GitHub. You can find this application. You can find steps to create sort of the same setup as I have described here, and you can totally check it out.
Thank you so much. I want to ask you if it's possible to join us in the chat. Maybe you can answer three more questions in chat to our audience. You just need to log in from your email and you can answer and communicate with our audience more if you can,
Right.
of course.
I'd love to do
And
that,
thank you.
and I would find you
Mhm.
there. Thank you for
Okay,
having me.
thank you so much. And thank you for joining us today.